For problem number 39, it says in a small town, there are only 2 AM radio stations, one at 900 kilohertz and one at 1280 kilohertz. What are their wavelengths of the radio what are the wavelengths of the radio waves transmitted at each station? So the relationship between wavelength, this is lambda, Greek letter lambda, and that always refers to wavelength. Yep. And then times the frequency. Now, this is interesting. Sometimes you'll see the letter F. Sometimes you'll see like a funny shaped V.
That's what we do in chemistry.
Yeah.
Yeah, I like the funny shaped V better.
The funny shaped V works out. It's like a V, or sometimes you'll see it like this,
Has a little curvy tail.
like that. Yeah.
Yeah, that's better.
We didn't like.
I didn't know like
But it means the same
It
thing.
was like,
Yeah,
it was like
yeah.
flick.
Let's use the V.
Yeah, same. It was like
Well, now I'm going to stick to my textbook. We'll use the F for frequency, okay? So this is the frequency, and I think I heard somebody shout out what C is. What's C?
Speed of light.
speed of light.
Yeah, this is speed of light. Somebody know what that is off the top of their head?
8.0 meters per second. Yeah,
Uh,
0.00 times 10 speed.
It's actually 2.99, like 96. But for most of our calculations, in fact, in the textbook, we will use C is equal to 3 times 10 to the 8th meters per second. Okay?
What's your grade point average?
Oh, but
I'm recording. So now, if I want to find
another one.
for station A, it is 920 kilohertz, right? It's kilohertz. That's 920 times 10 to the third hertz. For station B, it was 1280 kilohertz, which is 1280 times 10 to the third hertz, because we always want that unit in hertz, just plain hertz. Okay? All right. So now let's do this. So the wavelength of A is equal to C over the frequency of A, 3 times 10 to the 8th meters per second, all over the frequency, which is 920 times 10 to the third hertz. And if you multiply that out, it's 326 meters. So if you tune into an AM radio station and it's AM 920, the wavelength from peak to peak is 326 meters. That's a pretty long wave, right? Okay, so now let's do B. C times the frequency of B is equal to 3 times 10 to the 8th meters per second, all over 1280 times 10 to the 3 hertz. Because it's kilohertz is what they gave us. If you do the math on that, it's 234 meters. And so what I want to point out is because they are inversely proportional, as lambda increases, my frequency decreases and vice versa. I said that backwards. What I meant to say was lambda will decrease as the frequency increases.